This is the screencast for section 6.1, example 8. We're going to match slope fields with differential equations again, but this time they involve both x and y, so it's a little bit different. Use slope analysis to match each of the following differential equations with one of the slope fields, a through d. Do not use your graphing calculator. Dun dun dun. Alright, so number 1, dy dx equals x minus y. So a little bit analysis of that is that when x equals y, the slope is 0. If the point 1 comma 1, 2 comma 2, 3 comma 3. So I don't know, looking at these right away, these slope fields over here, can get a little overwhelming. What I like to do is, if I'm matching or just analyzing a slope field, I like to look at what's happening along the x-axis, what's happening along the y-axis, and then maybe what's happening in each quadrant if I have some sort of pattern there. So let's take a look. In this example A here, along the x-axis, all these are vertical little mini slopes, so vertical tangents, so their slope is undefined when y equals 0. When x equals 0, the slope is 0, those are horizontal tangents, and quadrant 1 and quadrant 3, our slopes go up to the right, so they are all positive, but then in quadrants 2 and quadrant 4, they are all negative. Alright, now how about B? Let's see, the slopes are, well, it looks like 0 on a diagonal where y equals x. So this is very similar to number 1 here. The slopes are also negative on this side. These are all down to the right, and these are all up to the right. And that's how I know that these are 0, because they have to change from negative to positive. I believe we have a theorem that says something about that. And then how about part C? Let's see. Let's see. So I see vertical tangents along the y-axis. These are all positive slopes in quadrant 1 and 3. Then quadrant 4 and 2 have negative slopes. And then those actually might even be horizontal slopes for 0 along the x-axis there. And then finally in part D, I got some positives and some well, you get the idea here. And then I have horizontal slopes along the x and y axis. Okay, so my analysis will help me with the rest of this. So when the slope, when x equals to y, is equal to y, I have a slope of 0. So here, that would be answer B. Number 2, x times y. X times y. Well, let's see, if I'm analyzing positives and negatives, I can say that, first of all, when x or y equals 0, the slope is 0. So far it's looking like D. But let's keep going. If x and y are both positive, so quadrant 1, or when x and y are both negative in quadrant 3, the slopes are positive. So 1 and 3 have positive slopes. Yep, still D. And then let's look at this. When x and y, when they have opposite signs, so quadrant 4 and 2, the slope is negative. So yep, that looks like slope field D to me. Number 3, the derivative equals x divided by y. Very similar to number 2 in that when you have the same signs for x and y, you have a positive, and the same signs for, and then opposite signs, you have a negative. So it's kind of looking like either C or A, but then we can add on a little bit of analysis that when y equals 0, the slope is undefined. So for that horizontal line y equals 0, we need an undefined slope. That's going to occur in slope field A. Now and you can also go as far as saying when x is 0, the slope is 0, which is also true in slope field A. Number 4, dy dx is y over x. So we can say that when x is 0, the slope is undefined. And then, so that looks like part C. And then also, like we said before, there might be some horizontal tangents. Well, yeah, because when y equals 0, the slope is 0. So that would be option C. The now try problem number 39 says match the differential equation with the appropriate slope field. Then use the slope field to sketch the graph of the particular solution through the highlighted point 3, 2. All slope fields are shown in the window -6 to 6 by -4 to 4. Okay, anyway. So 39, the derivative is negative y over x. So we can, let's start fresh, make a nice new analysis. Let's see, when y equals 0, the slope is 0. When x equals 0, the slope is undefined. When x and y have the same sign, so quadrants 1 and quadrant 3, normally it would be positive, but we got that negative sign, so the slope is going to be less than 0, which means then in quadrants 2 and quadrants 4, where x and y have opposite signs, usually the slope would be negative, but because we have that negative sign in front, that's going to make the slopes now greater than 0. So let's see, which one of those do we have? I like looking for horizontal tangents first. So horizontal tangents occur across the x-axis in this case, where y equals 0. So A's out, B is possible, C's out, D's out, E is possible, F is out. So we've got B or E. So let's see, in quadrants 1 and 3, we have negative slopes. 2 and 4, we have positive slopes. So it looks like B, and then yep, if I look at E, I have positive slopes in 1 and 2, and then negative slopes in 3 and 4. So B is definitely our answer. Now we just need to sketch the graph of the particular solution with a highlighted point 3, 2. So let's see here, that's going to go like this, and then like that. And you might be thinking, oh yeah, well there's probably another part over here too. Yeah, there might be, but remember we learned that if you have a particular solution, it only applies to the continuous part of the function. If there's a discontinuity, we still don't know what's happening past that discontinuity.